Hello, I am Orhun Gider, and this is the video for my Physics 101 experiment. In this experiment, our objective is to calculate the friction coefficients between a block of wood and a wooden inclined plane. Here, you can see a simple free body diagram of the block of wood in my experiment. The forces affecting the block are the gravitational force pulling the block and the normal force from the inclined plane. In this experiment, the angle indicated with theta is our incline angle, and it is measured in degrees. In the first part of the experiment, we are going to calculate the kinetic friction coefficient, and in the second part of the experiment, we are going to calculate the static friction coefficient. After that, we are going to compare our results with the reference results. Although, do note that these reference results are not perfect, as the friction coefficient between each surface may be different, and just because we are using the same materials does not mean that we will get the exact same coefficients from the reference. Friction is dependent on a number of things other than materials, like the bumps on an object. However, since both the block and the plane used in the experiment are smooth surfaces, it is safe to assume that the reference results and the theoretical results from the experiments will be close. In the first part of the experiment, we slide the block down the plane. We set the plane incline angle to something easy to work with, 30 degrees for example. Then, we release the object and measure the time it takes to reach the end of the plane. We know the angle of the plane, the time it takes for the mass to travel to the bottom, and the distance the block travels. So, we can calculate the kinetic friction coefficient using the formula detailed in the theory sections. We repeat this process 10 times to lower the margin of error. These are the results from the first part of the experiment. In the second part of the experiment, we set the block down again on the inclined plane. Then, we slowly raise the plane's incline angle and stop right when the object starts moving. We know the angle at which the object starts sliding, and we note it down. We repeat this process 10 times again to get a better average result. Then, we calculate the static friction coefficient using the formula mu s equals tan theta. Here are the results from the second part of the experiment. In conclusion, we have calculated the friction coefficients. We can also safely assume that the calculated coefficient values are close to reality, as they are almost identical as the ones in my reference book.